So the text is about a native app. If it were something completely different, it would look like this.
All right. John, come up here. We have a working group to run. So, as opposed to like earlier meetings, we're not spending the first 10 minutes of the meeting fiddling around with connectors to the projector, because the nice secretariat people provided that for us. All right. This is token binding at IETF 102, the final home stretch of the IETF in Montreal. And, this is the note well. Take a note of the note well, and I think you all know what it says. What we're going to do today is to briefly update you on core document ISG status, and then we're going to do proxy, and we're going to talk about attestation, and then open mic. If you think you're missing the 0 RTT and 1 RTT stuff here, that's because first of all, Nick couldn't be here, and he said sent a message that he hadn't really made any significant updates. So I think we're just going to cover those things on the list. So John, do you wanna do status update?
So we have a core document status update, which is kind of like, we're done. We're in the RFC editor queue for all 3 documents.
So I think you have to do that in the pink box. Okay. Yeah, let's do that again, because I'm not sure.
You want me to do it in the box?
Yeah, the interpretive dance celebration of core document. It is. All right.
This is the chair happy dance from getting the RFC editor queue for all 3 documents. I don't know how to dance.
It's fine. Just keep going. All right.
I could sing. We did that before.
Yeah, but it didn't turn out well.
Maybe at the end.
Yeah. All right. So yes, all core documents are in the ISG or in the RFC editor's queue as of like literally 5 minutes ago, which of course is a good thing. Yay to us for having done this. Very well done. All right. So, Brian, let's see if we can. There's a clicker here. Do you want it? Yeah. Oh, but that mic doesn't seem to work. Try fiddling with it or something.
How about turning it on?
There you go.
Big crowd here at the last Friday meeting. Thanks for coming out. Stating my name, I'm Brian Campbell with Ping Identity, and I'm here. I want to welcome you all to not San Francisco. It's a joke. This meeting was supposed to be in San Francisco. It got changed. Okay. I'm going to talk about HTTPS token binding with TLS terminating reverse proxies. Oh, I have this here.
Does it work?
No, that was user error. So just want to kind of cover what the problem statement is, why proposing this work and trying to push it forward. It's really common for HTTPS applications to be deployed behind some layer that terminates TLS, a reverse proxy or something like that, in front of the actual application. Terminates maybe a tough word because oftentimes TLS is reestablished with the backend, but the client connection to the application as the client knows is terminated by some sort of reverse proxy, and then content is passed back to the backend server, the application server. You see this in all sorts of things, in actual commercial products, in all sorts of open source implementations, Apache, Nginx, and more and more so now in as a service type deployments, Cloudflare, Amazon application layer load balancer. I'm sure Microsoft has some variant of that. And token binding is something we've all been working on in here, but in general for applications, the backend applications to take advantage of the benefits that token binding brings, some sort of information needs to go from that front end layer that's terminating TLS back to the application layer. In the absence of some kind of standard to facilitate this, everybody's going to do it different, which is a real pain for, I'm sure all of us have experienced in one way or another, or they won't do it at all, thus sort of undermining, the benefit of token binding or the potential for adoption. There's also an alarming shortage of acronyms in the world, so I wanted to thank Jeff for bringing TTRP to me after I fumbled over saying it and writing it a few times. So TTRP is TLS terminating reverse proxy, and sometimes say that for short. So that's why I'm here. The solution overview, the draft is now in draft 5, and basically it's to define a set of HTTP headers which enable the TTRP and the backend application to function together as though they're a single logical deployment of server-side HTTPS token binding. The TTRP gets the message, validates the token binding message passed in the normal sec token binding header, and removes it from the request it dispatches to the backend. What it does instead is, assuming it's valid, adds a new header, the sec provided token binding ID. It's a little long, but that's apparently how I name things. And it includes there the base64 URL encoded provided token binding ID directly in the request. If there's a referred token binding ID, it includes that with a different name, referred token binding ID, same encoding. And then kind of for extensibility, there's the sec other token binding ID header, which then is formatted as a comma separated list of additional token bindings, with each one with a hex of the type, which is just 1 byte, concatenated with a period, and then concatenated with the same encoding of the token binding ID itself. The solution requires some kind of trust between the TTRP and the backend server at deployment. And then it also requires the TTRP sanitizes these headers so the client doesn't inject them directly to bypass the security controls they get in. This is a very common pattern in reverse proxy type deployments. Just to give sort of a visual of the overview, sometimes it helped me. The client does sort of regular old-fashioned token binding over HTTPS with what it perceives to be the origin server or the server in general, which in this case is the TTRP. It negotiates it as usual, then starts sending the messages. The reverse proxy, the TTRP, validates the token binding message, sanitizes any headers, and then passes the encoded token binding and as the new header to the backend, just shown in here, and obviously the referred and the others as well, if applicable. And this allows the backend application server to bind cookies or other tokens to that token binding ID, or verify the binding thereof. A few changes and happenings since London. We've had a few reviews. Thank you for those that have done that. Published drafts 4 and 5. Largely editorial updates and clarifications, but I did add a section on TLS versions and best practices, pointed to BCP 195, and also made mention of Nick's token bind negotiation for TLS 1.3 draft, and mention of TLS 1.3 in general, just to sort of make it clear the expanded use and scope of this isn't just to TLS 1.2, but tried to make it sort of variable and so it would age a little bit better in the document. Just changed at a suggestion, changed to use the hexdig core ABNF rule for the encoded token binding type rather than and mention in the text the case insensitivity of it rather than spelling it out directly in ABNF. I sort of invented it myself first, and somebody pointed out there was a better definition to refer to, so I just did that there. Added some examples with the other type, editorial updates, and I added a few people, the reviewers, to the acknowledgement list, and I also removed the little piece that said, hey, let me know if you think you should be acknowledged and I forgot you. So that's not in the draft anymore, but it still stands. Please let me know. I wanted to provide a little bit of design motivation and rationale for the way things work as they do now. The main idea here was to make the common and simple usage simple. And that's particularly true targeted at the web application developer. That could be read as sort of a slight to a web application developer, but I can say that because I am one. It's good to make things simple for them. But we want to still make the other cases, the other things possible, which is something the working group has requested. So the overwhelming vast majority of usage of token binding is going to be the provided token binding. It's going to be the only one, and it's going to be in every HTTP request. And this, what do I do here? Oh, sorry, following my own notes. And just quoting a bit of the protocol here. Basically, it said token binding protocol implications should make token binding IDs available to the application as an opaque byte sequence. That's exactly what we're doing here. We're providing it as an encoded, because it has to be for HTTP, an encoded opaque byte sequence to the backend application. This is really simple for the application developer to do token binding if the rest of the infrastructure is in place. They just grab one well-known named header and use the value. Done. That's it. The same is true for referred token binding in terms of usage. It's simple because it's specified and we know what it is. It is probably going to be a distant second in terms of usage, and it's for a relatively specialized use case, which is an IDP or a token provider or some entity that's issuing tokens for another domain, which is less common but still valuable. Let's try to make that case simple as well. Same pattern. And then we have 254 other currently undefined token binding types, with some text quoted in here about sort of how they should be used and shouldn't used. They should be ignored, but they could possibly contain them. So really, it takes a proxy that knows what the type is to pass it along, and a backend application that knows what to do with it. But a somewhat more complicated encoding of the type and a string concatenation of the encoded value is used to allow for all these other types to be passed. So it's not restricted in that context, but it is intentionally a different encoding type to keep the simple cases as simple as possible while still allowing for the more complex cases. So leaving Montreal as the core 3 documents, I'm not going to dance, but thanks, John, for that. Go to RFC. I'm basically at this point going to ask, request that we consider moving this to working group last call. And then because we're in Canada, I am polite and said please, and I did it in French because we're in Montreal.
S'il vous plaît.
S'il vous plaît. Merci.
Open working group question. Does anybody feel that this isn't ready to go to working group last call? Does anybody feel that it is ready to go to the working group last call? Anybody want to say anything? We can do a hum. But if nobody has comments at the mic on this, I'm ready to go hum. And here's Dick.
Dick Hart, Amazon. I think, if we're going to have token binding deployed, we're going to need something like this.
All right. I think we're going to do a hum now. Two options, for and against, during a working group last call. We'll confirm on the list. And hum now if you support. Or Stefan, did you want to say something?
Yeah, just a short question. I asked you before whether there would be any reason to provide any means to authenticate for the application server to authenticate that the relayed token binding information actually comes from the reverse proxy. And you said, well, you don't want to do that extra complexity. I still have a question whether if there would be a good reason in the future, is there an extensibility possibility where you could add that in some sense if it would be important?
So one comment on that is that there's still something required. It's just not specified the mechanism within the draft. So yeah. The proxy should authenticate to the backend with mutual TLS, with private network and restricted IPs, with some other authentication. so that it knows that's where it's coming from. There was discussion in this group, but it wouldn't be appropriate to do it in this group, of defining a more generalized mechanism for a reverse proxy to convey to a backend which headers it had in fact looked at and processed to do that as a more standardized mechanism. There didn't seem to be the appetite in the HTTP working group to go forward with that. If in fact, though, that was work that was undertaken, my expectation would be that it would be generalized such that it could be applied to any specific header used in this kind of context, security aware context between the proxy and the backend, and thus this would be as applicable as any other similar content to that kind of protection.
Because I think this is, as the former speaker, this is going to be very important, and I just wonder if the door is closed completely to add that type of.
I do not think it's closed completely. It certainly didn't do anything
we did have a conversation with the relevant other working group. It was a consensus and discussed here with the electors that this is not the place to do it, right? This is not the working group to do it, and it's a general problem. But so far, there hasn't been appetite to do it. That doesn't preclude, anybody, including you, right, from going to go to the HTTP working group and say, hey, I need to solve this problem. Would you consider a draft?
And I think the main
that's the appropriate thing.
Point and concern of the question was, if in fact that happened, is there anything in here that might preclude it from working with that? And there's certainly nothing that I'm aware of or put in there intentionally. It should be fine and applicable to that kind of thing.
Okay.
So Martin Thompson, I think there are too many options in this space for us to actually nail anything down concretely. We're talking about attestations, client authentication. I don't think the suggestion of a private network is actually a good one, but
it happens.
It happens, unfortunately. SSL added and removed here. I remind everyone. I noticed that there's nothing in the draft on this point. Certainly not in the security considerations. I couldn't find anything specifically on that point. I think it's probably elsewhere, but it's probably worth calling out really, really firmly that the expectations about who contributes is not.
So in my own mind as the writer, I thought I was pretty clear about it in the security considerations.
I'll double check.
But
comment
and if it's not, it should be. So I agree with you, but my intent was to have that spelled out both.
Yeah, it's in it's hidden under something else. Yeah, that's fine.
Okay.
I'll see
if I can make it clear, please.
So if we do if we actually get to HUM and actually do a working group loss call today, right? In that case, would you be okay like doing that as a working group last call review?
Yeah, that's kind of what I intended to do.
Excellent.
Beautiful.
I actually got up to say one thing, which is that you can just decide to do a working group last call at this point. You're not aware of any open issues. No one else is raising any. I don't think we need a HUM for that. I'm certainly not going to get a HUM in a room with this few people in it. So
fair enough. But now that I've said I was going to HUM them.
If you want us to HUM on something, I'm sure.
Let's just do it now. Who's in favor of doing a working group close call on this?
Yeah.
All right. Anybody opposed? All right. Very good.
In favor of Brian Shorts?
And flip-flops. I dressed up for you all.
Okay.
All right.
Jake, okay.
All right. We're doing it. All right.
I'm done. Thank you all.
I think that's it. Yeah. All right. Let's see. Is Giri Mandiam here? Perfect. Let's see if I can separate this. There we go. All right.
Here, would you like the implement of Doom?
Sure, why not? I think speaking of clothing, Jeff has said this is the first time he's ever seen me in casual clothes, so I'm waiting for Tony to follow our lead. So this is a continuation of tested TLS token binding. This draft has been in the group for a couple years now, but we only started seriously considering it as of London. I'll apologize to the group because I did submit a revision this week. I don't think that that's normally the way I generally like to do things, putting a draft on everybody's plate during the meeting, but I actually got some very good feedback in the past couple of weeks from Andre Microsoft, and I thought it was good to implement it as much as I could. So I'll try. So I'll go over this. Can we go to the next slide, John?
Or you can just click.
Oh, okay.
And
There you go.
all right.
Okay. So, to give a recap of, well, I think everybody knows what TLS token binding is about. It's a little bit more than just bearer tokens. It's also proof of possession of a private key. And the current specification requires that the EKM be signed. And there's also the so-called token binding type, token binding key parameters. Those have to be exchanged as part of the whole message flow. So where does attestation come in? The browser could maintain private keys associated with token mining, but the problem is that user agents are in user space, and therefore they're subject to potential compromise, and particularly browser maintained key stores are vulnerable. We've seen some advances, in platforms to actually better protect key stores, but right now, I think we see with a lot of TLS token binding implementations that that's what we have: user space protection of keys. Native applications, it's not much better. There's a lot of reliance on open source libraries. There's code obfuscation, and and basically crossing your fingers that your binaries don't get reverse engineered. So, I mean, even if you're talking about native clients implementing TLS token binding, if they maintain a private key store, there are still vulnerabilities with that. So this is where attestation comes in. So attestation, one definition is given here. Now, I know we've had two barb-offs this week where we discussed a lot of different views on what attestation or remote attestation is about, but it's generally a piece of software providing information that's cryptographically verifiable about the environment in which the private key is stored, specifically in the case of token binding. It could also be more general purpose about the security profile of the device. And you can include several things in there, including the health of the device. For instance, Android Safety Net attestation is an example where you actually get a runtime assessment of the integrity of the operating system. Another thing could be enumeration of third-party applications in the environment where the token bind implementation is running, and more specifically where the key store is stored. Some of those applications may be malware. Also, any suspicious events that may have occurred on the device. So attestation data is generally combined in a structured format, and then is signed, potentially encrypted, so that it's cryptographically verifiable at the relying party. This is a recap. Sorry, this isn't coming up perfect on the scroll through. Yeah. So if we look at the current draft for the TOKBIND protocol, specifically was called out where the extensions are defined that attestation is envisioned as a potential extension. So this is kind of treading a little bit of new ground now that we have the three main drafts going into RFC status. Now we can go ahead and say, okay, how do we want to define extensions? This is the first draft that I can see where we've actually tried to define an extension, and it's consistent with what I think the vision was of the group when extensions were when the extension mechanism was defined in the first place. So, based on input from the last meeting, I was told to reach out to the Chrome and the Edge teams to see what should be the initial attestation formats, and there are a couple of things that have been pretty clear. The Chrome team is maintaining a browser-based key store. You could provide an attestation for that. I didn't really see a point. I'm hoping that one day we'll get to a point where there's enough performant key store implementations where Chrome will be able to move off from a user space maintained key store. So I defined an Android key store attestation as one of the initial formats in anticipation of that. That's open to any input from the group. For Edge, there's also a problem with a problem there as far as performance is concerned for TPM-based key stores. I think, though, based on some offline discussions, Microsoft will come in if this draft goes forward. Microsoft will come in to extend it with their preferred approach, using a more performant key store than a TPM. I put in a TPM just to boot, just to seed this attestation. These attestation will hopefully eventually become an attestation registry for token binding. Yeah.
Why 1.2, not 2.0?
Pardon?
TPM 1.2.
Yes.
For our remote attendees, please.
My question was, Eric, not Mark, by the way, why are you specifying explicitly version 1.2 as opposed to 2.0? Is there any difference in this respect in terms of key store?
Go down. Borrowed heavily from WebAuthn. And WebAuthn, we defined it with respect to 1.2. My interpretation was that this isn't kind of the general TPM attestation that you see as part of the secure boot, that you see generated secure boot. This is something specific to the token binding operation. And I thought the version 1.2 solution was sufficient for that. But yeah, there's a lot of different. This isn't even the only TPM attestation in the spec. In the WebAuthn spec, there's also an ECDAA version of attestation as well. I'm open to other things. The 1.2 I thought was pretty well understood. It's 509 based. You could it serves a job for this particular purpose.
Okay.
Yeah. So all the current proposed attestations that I have in the spec are based on signing of the EKM. For people in the room who have actually been following the WebAuthn spec and want to compare it, and like I said, I borrowed heavily from that because there was a lot of hard work, not so much just for the Android key store, but for interpreting the TCG specifications for the TPM attestation that I wanted to leverage. There are some primary differences. The WebAuthn attestation signature is over a combination of what they call client data and auth data. The client data, client data incorporates the challenge, a server-generated challenge. In this case, I didn't see a need for a server-generated challenge because we have EKM, so that binds to the TLS session. It works for the token binding message. I didn't see why it couldn't work for the attestation. Other thing is WebAuthn requires the transmission of the actual algorithm used outside of the certs. I personally worry about such things because there's always a slim possibility that the algorithm you received out of band could not be the same. It may not be the same as what you receive in the X509. So I just say, okay, let's leverage the algorithm field in the certificate. But even that's something that is easy to separate out, and if it helps out the relying party for quicker verification, we can do that. Yeah, Eric.
Can you say what you just said about X509 and the algorithm?
Yeah, there's an algorithm field in Android Key Store. I believe there's an algorithm field in the 509 for the TPM attestation. So Android Key Store attestation is basically a 509 cert. There's nothing else. Yeah.
Okay, just because like 509, the alg IDs don't correspond one-to-one with actual signature algorithms.
Yeah. Okay. So I think I need to go back and verify this with the TPM. The 509 for Android Key Store, I'm pretty confident that that's the, as far as I can tell, that's the algorithm that was used for the creation of the signature. The thing is, though, if you read Google's documentation, they don't specifically require inclusion of that field in the cert.
Sure. I'm just saying that, like, that, 509 keys are like a type RSA encryption. And so it could be any signature, it could be any hash, it could be PSS or PKCS1, and you can't tell. Or it may be RSA encryption. And the same thing is true, quasi-true for, like, sometimes for EC. So, like, You can't go for the 509 cert necessarily to know what's in your deployed.
Yeah. So actually, while I got you online, so what is your recommendation if the client, the client, in this case, the token buying client, knows what algorithm it used to create the signature because it commanded whatever key store to create that signature. So what should a relying party do when the algorithm conveyed by the client is different from the algorithm in the cert?
Well, I guess it depends on what you mean by, so the algorithm in the cert tells you, so there are two algorithms in the cert, obviously. One's the one that covers the cert signature, which you ignore, and the other one that tells you what kind of key you have. Those do need to match up, or you got them, or it's not going to work, right? Yeah, I think so you mean it's the algorithm in the cert is like ECDSA and the one with one group and it's like claims to be like ECDSA one group and like another group. I don't know. Those are errors, right?
Yeah. Okay, so I'll do that, and I'll say for next version I'll just separate out algorithm. I think that there's some efficiencies for doing that, but like I said, that's the one thing that I've kind of been scratching my head over, and I think for WebAuthn I'm scratching my head over that too. Okay, can we go down? Okay, so this is actually kind of a big change, and I'm not sure if the group wants to do this, I'm not even sure it belongs in. I'm not even sure this mechanism belongs in this draft. Basically, unfortunately, Dirk and the rest of the Google guys don't seem to be here today, and I don't like talking about people when they're not here. Okay, yes, Arnar. Okay, so Dirk conveyed to me in a one-on-one discussion, and he said that there needs to be a mechanism for suppressing an attestation in case the relying party isn't interested in wasting bits over the wire on that. So I kind of looked at it a little bit. I kind of looked at it and said, well, what would be the best way to do this? And I thought that a simple way to do it is the way we treat cipher suites in the TLS handshake. And therefore, I proposed a new TLS extension code point for token binding sessions when extensions are used, where the client hello includes a list of supported extensions, and the server hello would include a subset of those extensions listed in the client list. Now, I've been scratching my head over this a lot. First off, you're bloating the TLS handshake, which is not particularly fun. Second thing is, I don't like the idea of defining a different TalkBind TLS extension code point. I'd rather use the one that's already there. Third thing is, I'm still not sure if servers have an interest in suppressing extensions in which they have no interest in, because they can always ignore them. So, yeah.
Andrei Popov, Microsoft. So the bigger issue with this proposal, I think, is that it doesn't solve the stated problem. If the stated problem is that the client avoids generating, an attestation statement, which can be expensive, and putting a lot of bytes on the wire, because those statements tend to be large, right? Because they involve certificate chain and stuff, certificate chain. So if that's the goal, then just saying, hey, I support attestation, and then waiting for the server to respond doesn't solve this problem. It should be much more expressive than that. You have to say, I support TPM attestation, PSM attestation, key store attestation, whatever you support. And the server has to say, well, I can verify this type of attestation with these, possibly even with these trusted roots or not. That's a separate question of, do we want to send trusted roots that we trust? But we want to at least agree on the type of attestation we do, and possibly the signature algorithms we're willing to verify, and all of that stuff. So I think, just advertising support for this extension is not very helpful.
So we discussed this quite a bit in WebAuthn as well, and I think the balance between we wanted to basically follow the W3C's device fingerprinting guidance, which is minimizing exposure of potential privacy violating information, which could include additional device capabilities. So, if we feel this risk isn't so much with a feature like token binding, then yeah, I think, advertising the capabilities is one thing. I think as far as trusted roots, and I think I corresponded with you on this privately, I actually proposed that in web authentication, where a server could actually say, these are my trust anchors that I'm interested in, and convey that to the browser so they could actually use that for selection of authenticators. And I was told in that context, at least, that service providers weren't interested in such a capability. So,
right. So I'm not insisting on the specific components. We can discuss them at length, like what needs to be negotiated. But I think it's more than saying I supported the station versus I do not support the station. And this mechanism does not solve that problem.
Yeah. So, fair enough. It's not very expressive. But I also wanted to, before I went into defining on that, I wanted to get the group's interest as to whether this is even something worth pursuing in the context of token binding, and that is basically having an ability to negotiate extensions and therefore, ergo, not having the client send extensions in which the server has no interest in. And I agree that for a server to make an informed decision, it should be a lot more probably than saying I just support extensions. It should be I just support attestation. It should be what types, and potentially even what routes, if you want to even go that far. It's an open question. I don't know.
Right. So to this question, Andrei Popov, Microsoft again. So to this question, I think that it's kind of overkill to advertise your extensions before you send them. The draft currently says that the server ignores extensions that the server doesn't understand. It's as if in TLS first you negotiated that you will send SNI, then you sent SNI. It seems like a second layer of negotiation that so far I don't see the use for, but let's see.
Okay. Thanks, Andre. If the group feels it doesn't need it, then I don't even need to define a new extension code point. So what that means is that you can live with the existing TLS TOKBIND extension code point, and then the client supports an extension. It sends it off. The server is interested in it. It goes ahead and parses and interprets it and acts upon it, or it just ignores it, tosses it to the ground. Arnar.
It's Arnar from Google. So I haven't spoken explicitly to Dirk about this, but to try to interpret his, I think one of the issues is that it's not just about support. It's also about, if you're comparing to WebAuthn, the reason that we have the attestation conveyance preference there is that in many cases, the server explicitly does not want attestation because it's privacy revealed. Mm-hmm. And server may not want that. That could be because the server does not want that data because it ends up in logs. It could also be because in WebAuthn, the client or the browser may actually throw up extra UI for that, and that's probably a concern that is not necessarily valid in the context of token binding. But it's not just about support and optimizing what goes on the wire, but it's also it's one of the other reasons for the preference.
Yeah, I thought about that too. So there's two. So one of the things we talked about in WebAuthn, not just with attestation, but extensions in general, is that the attestation was originating outside of the browser. Therefore, it was a privacy violating. The browser wouldn't necessarily be able to do anything about it. It couldn't modify the data without killing the signature, right? I think in this case, though, the TOKBIND stack is fully controlled by the browser. So at least if the browser feels that, okay, I don't have the user permission for this, it can suppress it. And the server just would never receive the extension. I think the problem's a little bit better bound in the TOKBIND context. Tell you what, can you go back to Dirk and ask him if this is really necessary? Because you've heard Andre's opinion on this, and this is what I've heard privately from Dirk. He hasn't.
So can I make a suggestion? Yeah. If no, we're not. I mean, this is not a working group document, and we haven't even talked about that yet. But what I would suggest is that you go talk to the TLS working group about this, because it seems to me that you're going to have like similar situations in other extensions where, for instance, encrypted SNI, right? Where the client is deciding to send the SNI information to the server, and the server doesn't have a say whether the client does that or not, right? There's no asking the server, are you okay with me sending an SNI request, right? Before you send the SNI request. So, and this sort of seems to me to be like a similar situation, right? So, maybe have a conversation with the TLS folks, some of whom are in the room, right? To figure out whether this even makes sense to try to get out of this problem. Right?
I'm not sure I'm quite following the problem.
Yeah. So
here's the thing, right? Attestation being one example, there could be situations where the server is not interested in the in an extension, a TOKBIND extension that's being produced by the client.
Right.
Now, in the latest ID, I put in a way for the server to suppress this particular extension, but it's kind of more general. It can be used with all extensions.
Well, what problem were you trying to solve?
So there's so as Arner had brought up, I think you left the room for a second. If for instance, like an attestation extension is potentially includes privacy tracking information, a server may say, "Look, I don't want you to send it at all."
But yeah, the client code. Well, I guess the attestation extension, like, why is that attestation extension being tied to TLS rather than token binding?
No, it is token
isn't.
binding. I was talking about a new.
No, I know, but my point is that okay. So like the way TLS handshake works, right, is the client gets his extensions first, and the server sends his extensions, right? And so if you want to send if you want an attestation, so if you're saying I support attestation, which is that the extension I support attestation, or does it like contain the attestation information?
It's I support attestation. The attestation information.
Yeah, the way TLS works is like basically you get to advertise what you support, and like lots of shit in TLS that like leaks like kind of fingerprint information about your client, and maybe we should solve that problem, but like we're like not gonna solve it here.
Yeah. So in this case, the way I kind of propose it, just to summarize, is that the client sends a list of extensions it supports. One of them could be attestation. The server sends a list of what he would select among that he could support. And if it's not interested in attestation, it would just say no. Yeah.
So the problem is like, so how long does that information last? So, but then like, we're saying the next time I connect, I don't send the attestation extension.
Yeah, you wouldn't. The client would never include that in the TOKBIND message. Is what it would happen.
Well,
it would never include an extension that the server says it doesn't support.
Well, no, okay, wait a second. There's the client hello, and then there's the TOKBIND messages, right?
Yeah, the TOKBIND messages.
And so
the TOKBIND messages are where the extension data is included.
Good. Okay. So I mean, so the way TLS works now, right, is if you didn't want, if the client does attestation, but the server doesn't want it, then the pattern would be the client offers it, the server ignores it, and then the TOKBIND message doesn't have it. That's the pattern you expect now, right?
Okay.
So I guess what I'm saying is, if what you want is to suppress the client's offer of attestation, in the client hello, like at all, which, as I say, isn't what's required.
No, that's not what we want.
Okay, then I think you're fine already. I don't think it's changed anything.
Andre.
Yep, Andre Popov of Microsoft. So I would also say that the premise that the server will suppress attestation on privacy grounds, to me, doesn't make sense, because first of all, privacy of the client is something the client should be more concerned about than the server even. And I think any attestation mechanism that we devise should not create fingerprinting possibilities, like or client tracking or linkability possibilities. So I don't think that's the motivation.
Okay.
Yeah. So Martin Thompson, I think you've got it. The basic design is the same as with token binding. The client advertises the forms of attestation. Mm-hmm. It supports the server, lists the subset of those that it's willing to accept. And the advantage that you have in the case where the servers don't want particular forms of attestation is that the client doesn't have to generate them and doesn't spend the bytes on them. But that's exactly the same analysis as you have with the standard token binding. So, so nothing changes, no extra complication needed.
Okay, good. So I've got all right, thanks. So maybe Google, we can get a little bit more thought from you guys at R&R after you go back home. Thanks. Okay, so we have the open questions, and one of them I said, should there even be an extensions negotiation mechanism, because the server can always drop extensions that it doesn't care about. I'm personally not that convinced about saving bits over the wire for a client generated extension that the server doesn't care about, but maybe it could be a consideration in the future. Should supported attestation types be advertised? The current ID only says whether the client supports attestation. I was going by the WebAuthn model on that, but as Andre pointed out, it can be more expressive. Should supported attestation trust anchors be advertised? So that's another thing. That's another thing that's another item that we need to, I'd need to consider, and also the proper format. Andre, you'd suggest something. There's FQDNs and such to do that as well. Martin?
Yeah. So Martin Thompson, I think that the mechanism that we discussed just now covers the first 2 points. I don't think there's much value in us having a single Boolean value here. I mean, if you say you support attestation and there could potentially be multiple types of them, it sort of makes a bit more sense to actually negotiate the types.
Okay.
Don't advertise trust anchors. We don't do this anywhere else, and it's a quagmire. I don't know what the current list of initial.
Oh, that was basically that was basically TPM v2 and Android Key Store. That's
yeah.
And the verification procedures are related to that. That's you have to read the draft.
The situation with respect to attestations might be further improved by the other work that you're doing here, rather than trying to solve that problem here. We'll have to make a call as to how mature that work is with respect to those other things, and how well deployed it is before we get to that point. And that's probably a working group last call point that we make that sort of decision, or certainly much further down the path for this. And I don't know what the verification procedures are, but
yeah, no, that's fine. I mean, and I'm having to re-verify. We've been doing this in the context of WebAuthn as well. Fido is setting up a server certification program, so we're trying to actually do that. We're trying to actually make sure that those verification procedures are accurate.
So I have a question for you related to the verification stuff. We covered a large portion of the token binding header structure with the signature. We don't cover the extensions with the signature, do we? So we're going to have to make some sort of assessment about how the signature and the attestation interact with each other, such that we don't have any problems with, say, copy-paste attacks and all those sorts of other things.
And rip of Microsoft. That's a valid point. We'll need to think about that. But I think before we even get to that, there is a bigger issue, bigger open question I have for this. So in the current draft, it talks about using the TLS AKM in the attestation message validation and generation path, obviously, right? And so that to me does not make a lot of sense. We need to first figure out how long those attestation statements will last, whether they will be generated for every TLS session, which to me wouldn't make sense, right? So if I'm attesting the token binding key, I'm probably generating that statement once and it maybe lives for a while. So we need to kind of think about that basic question first.
Okay, so
what are we attesting to? Yeah. So the question there would be, what are we attesting to? Whether that be the fact that there is a key, or all of those things. Yeah.
So okay, that's fine. I mean, an attestation signature, and I'm talking about the attestation signature specifically, not the TOKBIND message signature. To me, it doesn't make sense unless there's to me, it doesn't make sense generating it without a potential to prevent replay, right? And the EKM just seemed like low-hanging fruit in order to create the challenge data. I mean, we can do some, but that was what my motivation was behind that, right?
So again, Andrei Popov, Microsoft. So the replay is mitigated, in my opinion, by providing a token binding signature and the token binding message on every, and that is based on the KM, right? But my thinking was that the attestation draft is about attesting to the fact that the token binding key that I'm using is actually stored securely, in some either NTPM and VSM, whatever it is, in the key store. So I'm thinking that actual attestation statement does not need to be generated every time, but of course the token binding key will sign the AKM every time as it does in token binding.
Okay. So what would you be thinking of as far as how the attestation signature would be generated? Over which data would it be generated?
I think that it would be just a signature with the, like in any attestation mechanism that I'm aware of, and I'm not an attestation expert by any stretch of the imagination, but basically there is an attesting key that will sign probably the public portion of the token binding key, or something based, or something including that, right? So basically it's a signature over the token binding key.
If that's the method that's adopted, then that would be, yes, you're right. That signature would not be generated on every TLS connection. Yeah.
Yeah, Martin Thompson, I think that's about right. I think you need to contextualize that a little, saying that there's a token binding and this is a token binding key, and put some sort of parameters around that. But
okay,
so I think that would be sufficient. And I don't know what the performance characteristics are here, but I think it would, I mean, as long as that is sufficient, that has some pretty nice performance characteristics.
Yeah,
so it would make things a little bit easier to do. And you could potentially omit it in subsequent token bindings, potentially, depending on usage patterns. But that's a whole nother problem.
Yeah. Well, yeah, I can keep getting omitted. Maybe you'll have different relying parties, in particular using a TTRP in the middle, right? So, right. And they can. Yeah, no, that's fine. We can do that. We can create a signature over the public key, in that way it doesn't change per connection, and and we rely on anti-replay through the token binding message itself in that signature. Perfectly valid. Yeah, that's solid input. I'll take that back. So.
Right, and repo of Microsoft. So if it saves us, a signature on every connection, that's a good thing. And the signature verification, potentially, if the server is able to cache maybe those things, we'll see. So the other thing is, if we were to sign the AKM, AKM is a bag of bytes. If your TPM is willing to attest to to sign like a random bag of bytes, that something is broken in that attestation. So just a comment on that.
Yeah. Fair enough. Okay. So that's something I need to correct. I'll get it. So I think first off, those are the open questions. I got some feedback on that. I think the second one needs to wait, adopting the IDEA standards track, until I get out a new version. The other thing too is I want to get the Google answers on what they want to see as far as extension negotiation and extension suppression are concerned. And also co-editors are welcomed. I will say, I will message to the chairs though, that even though once we get through this and this becomes a working group draft, then I think that opens up possibilities for people to extend the attestation registry. So my recommendation is not to let this drag out too long before making the decision to get the standards track.
Right. So getting to that, right? So it's sort of I think the limiting factor here are two things, right? How quickly can you spin another version and get some review on that? And then we actually have to ascertain that the working group is interested in working on this. Mm-hmm. And I think it has to happen very quickly, because now that the core documents are out and proxy is getting there, I don't think we're going to be around for that much longer if we don't have active work. So my suggestion here would be for you to spin a new version very quickly. And I'm going to ask a couple of questions to the working group, just sort of while I have everybody here, right? And I also want to ask a question of our AD, whether he thinks that this is actually in scope for the working group, because that's number one.
Yeah, that's actually why I got up. I'm looking at this. I'm looking at this, and I'm not. This does not look like it's in scope to me.
No, it's not. It's not obvious to me either, right?
I get to recharter.
Right. It could very well be a recharter, right? In which case, on the other hand, if the working group is really excited about that, I'm sure we could talk about it, right?
Not out of question.
Yeah, exactly, right? But I think that the one question I wanted to ask the working group right now is, how many have read this draft, or any of the versions of this draft? Let's say that. Yeah. All right. So it's a fair number, and I'm not actually gonna. I don't think we should ask for adoption today, but I want to. Right, but I want to get a sense of the room. How many here actually are interested in this work enough to keep working on it if there was a recharter? All right.
Yeah, sure. I'm just counting.
Yeah, are you scratching your head, Tony, or are you expressing interest? You're expressing interest. Both. All right, that's fine. All right.
So, I guess one thing that we would have to think about is there's concurrent attestation work going on in other parts of the IETF. I'm assuming you coordinate with those people, so I'm not saying that's a problem. Since they're also Qualcomm. Yeah, exactly. Right.
Yeah,
exactly. So, but it might be the case that if this is the only remaining work for TokeBind, that it would be better to consider doing it in that forum rather than trying to keep TokeBind alive, right? So that's something else to consider.
Absolutely.
Yeah. Okay.
But I think the quicker we get to a new version and some review of that, the quicker we get to the point where we can even have a discussion of where this goes, if it goes.
All right. So plan on seeing one next week.
Right.
All right. Thank you.
All right. Thank you. And that gets us to open mic. TLS 1.3. Yeah, we're gonna. What was? Remind me. We were gonna ask for.
Our author is.
Yeah.
Someplace.
Yeah, our author is not here. So I don't think we can do much. I think we'll have to do that on the list. I think there was I think he sort of raised. Yeah, he raised the question of whether it was ready for last call, right? So, there. I think we'll have to ask that on the list and see. Just as a quick show of hands, how many have read the last version of the TLS 1.3 draft? And I noticed Nick Sullivan was raising. You were raising your hand. Nick, since you've reviewed it, do you have any issues with that draft? As a TLS contributor? Yeah. All right, that's fine. All right, no, I think we'll have to do this on the list. All right, open mic. Or really?
The illustrious agenda had mentioned a fetch update. I was just wondering if.
Oh, that was a copy paste error from last time, actually. So yeah. I don't think anybody has a fetch update, but if there is a fetch update,
if there is ever one,
it'd be great.
It could be listed too. I'd be curious. That's all.
Mm-hmm.
So I just looked at Jeff Hodges. I just looked at the PR this morning. The original PR got closed, and because the conversation had gotten so long, it took minutes to load that page. Got moved to a new one. This was at the end of April. There's some outstanding comments on it from somebody whose name I'm blanking on right now. And Anupam has moved jobs in Google. It's on my list to add my review to it. I haven't gotten to it yet. There's a couple other things on top of the stack. So it's still a work in progress, but it's getting closer, it looked like. Last activity was in May.
All right. Thank you, everyone. It seems like we might meet in Thailand, but who knows? Yeah. All right. Thank you. And safe travels.
Jag behöver göra